Right, so today we're going to have a look at everything you need to know in order to complete the topic surds. So to begin with, we're going to look at the two surd rules that you need to learn. So the first one says root A multiplied by root B is equal to root AB. So for example, if I had root 3 multiplied by root 4, this would equal to 3 multiplied by 4, all under 1 square root, which is equal to root 12. If we apply a similar sort of technique for this next one, our second surd rule, it tells us that root A, so let's say root 20, over root B, means we can write this all under 1 surd, and it becomes 20 over 2, which in this example would equal to root 10. The multiplication rule, the first rule we met, is extremely important for our first topic that we're going to look at, which is simplifying surds. So if we have a look at this first question, it says simplify. In order to simplify a surd, you are always looking for a square number which is a factor of 75. It might help you to write out your square numbers at the top of your exam page when completing questions like this in your exam. So we're looking for a square number which goes into root 75. So I know that root 75 is equal to root 25 times by 3. And this is where our first surd rule comes in. So we're reversing that surd rule. That tells us that we're allowed to split up our surd into two separate surds. And the reason we've picked out a square number here becomes clear. So we can square root this square number, and that is equal to 5 times root 3. And then to finish this question off, just like in algebra, we do not need to write the times, and we just got 5 root 3. So again, having a look at this second question, we've got to simplify root 125. So again, I'm looking for a square number which is a factor of root 125. Well, I know that that is equal to 25 times 5. Using my surd rule first, I can split up my surd into root 25 times root 5. And again, the reason we've picked a square number which is a factor is because the square root of 25 is equal to 5. We can again just simplify this further because we don't need to write our multiplication in between our terms. So how they can apply this to a question in your GCSE paper, they might give you a question which looks like this. So it says express root 3 plus root 12 in the form a root 3, where a is an integer. So that tells us we need to get both of these surds as root 3. Well, the first one's already root 3, so we can leave that alone. But we're going to look at root 12. So again, you want to pick out a square number which is a factor of root 12. Well, I know 4 multiplied by 3 is 12. So then I can split up my surds and I can square root my square number. And I get 2 root 3. So if we go back to the question now, we had root 3 plus root 12. Well, we've just worked out root 12 as 2 root 3. So now I have 1 root 3 plus 2 root 3, which means we've got 3 lots of this root 3. Again, you can picture this like we've done in algebra. If I asked you to do A, add 2A, you would tell me that we've got a total of 3A. It's the same thing here. We've got 1 lot of root 3 plus 2 lots of root 3 is equal to 3 lots of root 3. Question 2 again is asking us to express 5 root 27 in the form n root 3, where n is a positive integer, so a positive whole number. So again, I'm just going to look at the root 27 part to begin with. Again, we're looking for a square number which is a factor of root 27. So that must equal to root 9 times 3. I can split up my surd using my first surd rule backwards, and I can evaluate my square root of 9, and that's equal to 3 root 3, and we don't need the times between it. Got 5 root 27. Well, we've just worked out that root 27 is equal to 3 root 3. So this means I've got to do 5 lots of 3 root 3, which is equal to 15 lots of root 3. Okay, having a look at question 3. So this is our first surd question on expanding single brackets. So having a look at this, we have got root 5 multiplied by this bracket root 8 plus root 18. And this will link to our first surd rule. I'll just remind you of it. Okay, so we need to do root 5 multiplied by root 8 add root 5 multiplied by root 18. Well, here we can just times together our surds, remembering our first rule. That tells us we can write it all under one surd, and it would be 5 times 8, which is 40. We've then got under another surd 5 times by root 18, which equals to root 90. You will notice that it wants it written in the form a root 10. At the moment it's not in that form. We can't just add together the 40 and the 90. So what we need to do is simplify each part. So we're going to have a look at the left hand side, and we're going to simplify root 40 first of all. So again, just like before with all our simplification questions, we're looking for a square number which is a factor of 40, and that's 4 times 10. We can split up our surds into root 4, root 10, and we can evaluate our square root of a square number, and that's equal to 2 root 10. We're going to do exactly the same for the right hand side now. So root 90 is equal to 9 times 10, which we can split up as root 9 times root 10, which is equal to 3 root 10. So now my question becomes 2 root 10 add 3 root 10, which is equal to 5 root 10. It's asked for the answer for a, which is the number in front of that root 10. So a must equal to 5. Looking at question 4, it's very similar. We've got to expand our single brackets. So first of all, we've got to do root 3 multiplied by root 8 add root 3 multiplied by root 128. We use our first surd rule, which allows us to write this under one square root, and we do 3 multiplied by 8, which is 24, and we do 3 multiplied by 128, and that's equal to the square root of 384. So now we've got to try and get to the answer in the form a root 6. This gives you a bit of a hint as to how you're going to simplify your surd. So if you struggle to spot a square number which is a factor, you know that you're trying to make it something multiplied by this 6. So now 4 times 6 is 24, and 4 is a square number, and 384 divided by this 6 told you that you had 64 here. We can then separate our surds, so this becomes root 4 times root 6, and root 4 is equal to 2. We can simplify our surd on the right hand side. This is root 64 times root 6, which is 8 root 6. Our final step then is to add these two things together. 2 lots of root 6 plus 8 lots of root 6 is 10 lots of root 6. So therefore a must equal to 10. Okay, having a look at question 5, this is our first double bracket expansion. So what we need to do is 1 plus root 3 multiplied by itself. That's what that squared means at the top there. So now we've got a double bracket expansion. So we need to times 1 by 1, which equals to 1. And we multiply 1 by root 3, which is 1 lot of root 3. We've then got the same thing. We've got root 3 times 1. So we've got another 1 lot of root 3, followed by root 3 times root 3. And using our first surd rule, we know that that is equal to 9. Now we can work out what the square root of 9 is, and we can collect together our like terms. So we've got 1 root 3 plus another 1 root 3, which is 2 root 3, and the square root of 9 is 3. So finally we can collect together our 1 and 3, so we get 4 plus 2 root 3. So a is equal to 4, b is equal to 2. Now your teacher might have shown you a trick. When we multiply two surds, which are the same number, you don't need to multiply them because it is just equal to that number, because you are effectively squaring the square root, and they are inverse operations. So the rule your teacher might have shown you is root a multiplied by root a is a. This becomes particularly useful if you had a surd such as root 126 times root 126. You wouldn't want to have to times them together and then square root, but you would use this rule to show you that that is just equal to 126. Okay, so looking at question 6, again it's quite similar, however they've left some algebra in it. So we've got a plus root 8 times a plus root 8. I'd always recommend, even if they've written it as a squared, to write it out as double brackets. And now we expand. A multiplied by a is a squared. A multiplied by root 8 is a root 8. We've got a lots of that root 8. Root 8 times a is again a lots of root 8. And then finally root 8 times root 8 is just 8. So now we can collect together our like terms. So we've got a squared plus 8 plus 2 lots of a root 8, because you've got one lot of a root 8 here and a second lot of a root 8 here. You will then notice that this is not in the same form as our question, so we've got to do some extra work here. We've got to simplify this to a root 8. To do that, I'm just going to look at the root 8. I can simplify that like we did in the first question by picking out a square number which is a factor. That is equal to root 4 times root 2. The square root of 4 is 2, and our root 2 stays the same. So now we know we had 2a lots of this root 8, which we have just simplified to 2 root 2. So we've got a squared plus 8, that doesn't change, and then we've got 2a multiplied by 2, so that is equal to 4a root 2. So my expression for C is this a squared plus 8, and my expression for D is equal to 4a. Okay, so having a look at question 7, it asks you to rationalise the denominator. So if you have a surd on the bottom, then that is an irrational number. So any surd which is not a square number is irrational. So that's why it's asking you to rationalise it. What that means is you need to get rid of the surd on the bottom of your fraction, your denominator. In order to do that, we multiply both numerator and denominator by the same thing, by this root 5. If we multiply our numerators together, we get 10 lots of root 5. If we multiply our denominators together, we get this equal to 5. It gives you a hint in your exam, it wants it in the simplest form, so now we've just got to cancel our fraction down. 10 over 5 cancels down to 2, root 5. And then we're finished there. Question 8 again is very similar. This time we're timesing by root 7 over root 7, because we multiply by whatever our denominator is. We have to multiply both top and bottom by the same thing, because in effect what we're multiplying now is 1, because root 7 over root 7 is equal to 1. So therefore we're not changing our question. Now if we multiply our numerator, we get 3 root 7, and we multiply our denominator, we get 7. Just double check that you don't need to simplify. We can't simplify it, so that's your final answer. Again, another one to practice these key skills. So here we're multiplying both top and bottom by root 5 over root 5. That leaves us with 15 lots of root 5 on the top on our numerator and 5 on our denominator. 15 divided by 5 is the same as 3, so our final answer is 3 root 5. Okay, so having a look at this next question. It's similar to the questions above, but first of all we've got to work with our numerator and we've got to expand this double bracket. So that's the first step I'm going to complete. So we had 6 minus root 5 multiplied by 6 plus root 5. 6 multiplied by 6 is 36, 6 multiplied by positive root 5 is 6 root 5. Negative root 5 times by positive 6 is negative 6 root 5. And then finally, negative root 5 times positive root 5 is equal to negative 5. We can again see that we've got positive 6 root 5, subtract 6 root 5, so they just cancel each other out. That leaves us with 36, subtract 5, which is equal to 31. So my numerator is 31 over root 31. We still need to rationalise our denominator. So we do that by timesing both top and bottom by root 31. That leaves us with 31 root 31 on top and 31 on the bottom. We can then simplify. We do that by cancelling down. So 31 over 31 is equal to 1. So my final answer here is just root 31. Okay, a very similar question, number 11. We've got to expand our double brackets to begin with. So here we do 4 multiplied by 4, which is 16. 4 multiplied by root 3 is 4 root 3. Minus root 3 multiplied by 4 is minus 4 root 3. And minus root 3 times positive root 3 is negative 3. We can again cancel out our like terms. So here we had 4 root 3, subtract 4 root 3, which is 0. And then 16 subtract 3 is equal to 13. So my question now, my numerator is 13, my denominator is root 13, and now we can rationalise our denominators. We do that by multiplying both top and bottom by that denominator, root 13. That leaves us with 13 root 13 as my numerator and 13 as my denominator. I can then cancel out top and bottom, and that leaves me with root 13, and that's what the question has asked me to do. Okay, question 12. This is a slightly different question. It still wants you to rationalise the denominator. You can see that your surd on the denominator has changed to a rational number. So in order to do it, when you've got two terms on your denominator, you have to multiply both top and bottom by 5, and then we flip the sign of the second term. So because this was positive root 8, we change it to negative root 8, and you'll see why we've done that in a second. What I then do is I put brackets around my terms, because that reminds me that this is a double bracket expansion. So if we look at the numerator to begin with, we've got 3 plus root 2 multiplied by 5 subtract root 8, and we're going to multiply out. 3 times 5 is 15, 3 times minus root 8 is minus 3 root 8, root 2 times 5 is positive 5 root 2. Root 2 times negative root 8 is equal to negative root 16. We can then simplify our terms. So we've got 15, subtract. We can simplify our root 8, and that becomes root 4 times root 2 by picking out a square number, which is a factor. We've then got plus 5 root 2, and then we've subtracted root 16. We know root 16 is equal to negative 4. Here we're going to group together our 15 and our negative 4, and that's equal to 11. And we're going to continue simplifying this surd here. So this becomes minus 3, root 4 we know is 2, and then our root 2 stays the same, plus 5 root 2. So now my final step, we've got 11 at the front, negative 3 times 2 is negative 6 root 2, plus 5 root 2, and that's equal to 11 minus 1 root 2. Okay, negative 6 root 2 plus 5 root 2 is this negative 1 root 2. And that's our numerator. We now have a look at our denominator. This was asking us to do 5 root 8 multiplied by 5 minus root 8. 5 times 5 is 25. 5 times negative root 8 is negative 5 root 8. Root 8 times positive 5 is positive 5 root 8. Root 8 times negative root 8 is negative 8. Again, this one's slightly easier. We can see that the negative 5 root 8 plus the 5 root 8 cancel down, and we're left with 25 subtract 8. which is equal to 17. So your final step now is to put both parts together. So our numerator was 11 minus this 1 root 2, which we can just write as root 2, and our denominator was 17. And you can see that that matches our question at the top. So we're finished there. Okay, our last question to conclude our video. Again, this is similar to the question you've just seen above. So we have got 6 minus root 8 over root 2 minus 1. We again want to multiply top and bottom by root 2, but instead of it being negative 1, we need to flip the sign of our second term, so it becomes positive 1. Again, I put these in brackets to remind me that it's a double bracket expansion. Do each part separately. So I'm going to do my numerator first. 6 minus root 8 multiplied by root 2 plus 1. 6 multiplied by root 2 is 6 root 2. 6 multiplied by 1 is 6. Negative root 8 times root 2 is negative root 16. Negative root 8 times positive 1 is negative root 8. This is equal to 6 root 2 plus 6 minus root 16, well that's equal to minus 4 minus this root 8. That gives us 6 root 2 plus, or 6 subtract 4 is 2, minus root 8. You can again see that our answer currently does not look like it's in this form. So what we need to do is simplify this root 8. If we just think about what root 8 is up here, we can simplify that as 4 times 2, because we've picked out a square number which is a factor, and that's root 4 times root 2, which is 2 root 2. So now I've got 6 root 2 plus 2 minus 2 root 2, because that's what root 8 is equal to. 6 root 2 subtract 2 root 2 is 4 root 2, add this 2. Now we're going to look at our denominator. So we've got root 2 minus 1 multiplied by root 2 plus 1. 2 times root 2 is equal to 2. Root 2 times positive 1 is positive 1 root 2. Minus 1 times root 2 is negative 1 root 2. Minus 1 times 1 is equal to 1. We will again see that our root 2's cancel each other out, and then we're left with 2 subtract 1 on our denominator, which is equal to 1. Our final piece now is to piece the two pieces together. So our numerator was this 2 plus 4 root 2. Our denominator was 1, and now we've got it in the form that it's asked for. So A would equal to 2 and B would equal to 4.